Okay, thanks for joining us for the Western Wheels Conference. A couple quick things before we begin. If you need a certificate, you'll find the link for that here. You'll need to submit a separate request for each session that you attend, and you should receive your certificate in email within 24 hours of submitting the request. If there are any handouts available, you'll find those there. And if you're interested in learning more about any of the products featured in our sessions, that'll take you to the product page for each one. And if you click request pricing, that'll add it to your wish list. Here we are at the wish list. You can either complete the form and submit it right away, or you can keep browsing around and adding items to it to get one big quote. And you can always get back to your wish list right up here in the top right-hand corner. That's it. I hope you enjoy the session, and we'll see you on the other side.
Okay, so here we have the EC490 diesel aftertreatment system that we developed, and probably some of you have these in your classroom, in your shop. This is designed to fit through a classroom door and give instruction on. It's covered with a we call it the aquarium cover, so students can't stick their fingers in the substrate and mess with any of the wiring. We're going to talk a bit about selective catalytic reduction. The diesel exhaust fluid, we'll bring in a little bit of chemistry and testing. I'll bring some news from industry of what's going on with diesel exhaust fluid, some problems we're seeing. And then, of course, the diesel particulate filter, whereas this is the part of the exhaust after-treatment system that needs to have regeneration done so that we can offload some of the soot generated by the engine and turn it into ash that will not make it through the filter. So the chemistry part of this is, if we're going to take this in an equation and figure out what comes out the end of the exhaust pipe, we would do this. And that last little portion in the blue is what comes out at the end. Now, I think it's important that students understand that things come out at the end. I'm not so sure that they need to work the whole equation to understand the operation of the system, but they need to understand the constituent gases that we're using within this system. And they're just the things that we're around every day and we probably should be aware of. So let's go down that road a little bit. So understanding that our atmosphere is made up of 78% nitrogen and 20% oxygen, and then other constituent gases like argon, and I won't do the bad joke with argon again, but nitrogen is a real problem in our combustion because it makes up such a large portion of the volume that we end up putting out some oxides of nitrogen, or NOx, because of our equation. So here I'm going to give you some information. I'm going to use a Ford document, excuse me, from 2017 to get a good look at the system. That document is available on the internet most anywhere you search, or when you search correctly. Let me show you where it's at. So if you type in the DOB DSM, I started with 1601. This means that it's 2016. And if I put a 7 in there, that means that I get to 2017 document. So I can go backwards. I think 2018 might be available, but they're available all the way down into the 7.3 liter engines. So it's an interesting thing. I'm not going to share those out for you because it's easy to search for and the PDFs are free. So there's that link for that. We're going to go through that in a minute. As soon as I switch screens. So what I have is this document up on the screen. I've mirrored it with my iPad because I kind of like drawing with my iPad. It's easier for me to do. And we're going to look at the system from the beginning, because I'm going to make a point about this air that enters the system here. Okay. We go over here to this device over here, which is the cold side of the turbocharger. This is the compressor. And we're going to take that inlet air and we're going to compress it. But before we get to there, look at what we were doing here in the front of it, and I just marked it out, is we've got MAF and inlet air temperature. So we're measuring the air in, and we're going to measure the air out, or the atmosphere coming out, or the exhaust coming out. So if there's any losses or inconsistencies within the system, there's a plethora of sensors and things that are going to happen if this isn't correct. So let me switch colors. So we've pressurized the air. We're going to take it through the intercooler to cool that air, and we're going to come up to both banks of the engine. Scroll down. And we're going to work on this part of the system now. So we get through the engine, and coming out of the cylinders, you can see the banks. There's the one starts with 4, one starts with 8. We're going to come through. We're going to go through. We're going to hit the hot side of the turbo to spin that turbine so that it'll turn the compressor. And then we're going to go up through the system, through the selective catalytic reduction. And in this case, we're going to go through the diesel particulate filter. I'll talk about those differences in systems in a little bit. And then on out the end of the exhaust to be returned to the atmosphere. So let's look at a few of the points along this system. So we've measured the air in. Of course, we're paying attention to the crankcase ventilation as well. You know, there's a lot of stuff going on here. We've got a throttling valve here. All of these sensors are listed up in the key. So that this is a really good, in my view, this is a very good system schematic for student learning, because all the things are there and then they're in their proper place. And then they're also somewhat separated by system. So here at the top left corner, you see the selective catalytic reduction system, which includes the urea tank, the pump, the heaters, because the tank is heated, the lines are heated, there's pressure sensors, and there's injectors that are going to inject it into the exhaust stream. So this, I believe, is a pretty good document to show your students what's going on in the system. So we designed this HV490 or EC490 to be very visual for the students. And so we went through the PowerPoint. Now let's look at the system architecture a little bit more in depth. A couple of points that I would like to make. Let me switch my pointer here. Laser pointer. We're going to work from the top left. This is over here would be the exhaust in, or coming out of the turbocharger. We come to the diesel oxidation catalyst, where we take care of hydrocarbons. I'm not going to get into oxidation catalysts because, you know, they've been around since the middle 1970s and we've been dealing with them. We kind of know how these work. So then we come to the dosing valve, or the DEF fluid injector, you'll hear it called. Several different names, but it's all relating to injecting diesel exhaust fluid to deal with the selective catalytic reduction. The first thing the fluid hits in the stream, and this is an injector more like a garden hose nozzle, not a highly targeted fuel injection nozzle. So a 30,000-pound diesel fuel injection event that may be happening further up into the engine is not what's happening here. This is low pressure stuff, and I don't have that pressure figure, but it's not. It's well under. I think it's under 100 psi, probably under 50. So this hits a grill here because within the stream it needs to mix the diesel exhaust fluid into the exhaust stream so that the proper reactions can happen. So it hits kind of a louver grill here, and then it comes into what they call the decomposition chamber, where the DEF fluid is decomposed into other elements, and it's swirled around and mixed. It's run through the chopper, and this is all stationary. I'm joking about a chopper, and then it comes out, and then the flow is this way. Okay, it flows down and is going to change directions. So, you know, we've talked about this a lot when we were designing this. This unit is just under 8 feet long when it's all together. So about 7 feet long. We decided, in order to have it fit through a classroom door and not occupy a huge amount of space, and to facilitate our cutting it open, let's cut it open and place it on the board so that we have room to do it. So we come through the system. We go through, in this case, the selective catalytic reduction unit. Most heavy trucks with a single canister system, if you buy a 2021 pack car or a Freightliner product, Daimler product, this is going to be at the end of the stream, not at the beginning of the stream. Everything I've found from manufacturers is it's strictly up to the engineers on how they design this. So it makes no difference in the operation. You're going to still get the same things out the end. And then we take all the NOx out, and then we have to take the particulate out. We take these from, these are salvaged, so you can see that there is carbon particulate in this DPF, diesel particulate filter. Once again, a little more close up, we see the exhaust come in, go through the diesel oxidation catalyst, through the dosing chamber, decomposition chamber, we slide on down, we go through the selective catalytic reduction, or SCR unit, and into the diesel particulate filter. What's really unique in our EC490 is that we've assigned colored LEDs to demonstrate what is happening in the system. Now, we've got videos on our website and also on our YouTube channel, ConsuLab YouTube channel, that show the operation of these lights. And you can speed up the system. You can make the lights flash shorter or longer, or you can target one portion of the system. Let's say we only want to explore what is in the selective catalytic reduction unit. We can highlight that system, and we can highlight the lights that are illuminated to show which gases are where as we go through the system. Now, we really wanted that visual. I don't know about you guys, but I am almost embarrassingly too visual. I have to see it. I want to see it to really cement it home. So in whatever we do at ConsuLab, we always try to make sure that we can see it if it's possible. We can see current voltage when we use an oscilloscope, and we all like to use oscilloscopes. So this is just another example of trying to make it visual for everyone. It may seem like I spent an awful lot of time laying the groundwork here, but it's going to be important. So this is one of the first exercises that we developed for the students, was wayfinding in the system. So how do they find their way through the system? Well, we think that, you know, you need to assign a name to these things. You need to locate these components. We supply all the documentation, like that Ford document. You know, with the Ford document, you can easily go through and identify this as the cold side of the turbo. This is the hot side of the turbo. This is the exhaust stream. This is the diesel oxidation catalyst. Here's our DEF fluid injector. Here's our recomposition tube or decomposition tube. And then we turn the corner, and then we're going to change directions and go this way so that we can get into the selective catalytic reduction unit, the diesel particulate filter, and of course, since it has to sound cool, we need to have a resonator as well. And here they are labeled. So within the instructional materials and student assignments that come with this are all these pieces for the students to locate, and this will be things that they would hand in as an assignment. So let's take that down a little further. That's really bright after that black slide, isn't it? So let's trace the gases as we go through. This is our chemistry lesson for the day. So here we are. This is directly from the engine exiting the turbocharger. So we have hydrocarbons, oxygen, our lovely carbon monoxide, NOx that we're trying to get rid of as well. And this isn't a gas, but this is particulate matter. So this is the soot that comes through. So this is, you know, let me reference back again to the, you've got an engine that's, you know, it's pretty tired, and, you know, you're starting to burn oil. And where's that oil go? Well, a lot of it goes out the exhaust as soot. So, you know, that's particulate matter. Diesel oxidation catalyst is not going to do anything for us there. It'll help the unburned, but, you know, there's still going to be some soot if we're burning oil. So these gases enter the exhaust stream. We're measuring temperature. Everywhere we go in exhaust systems, we're measuring temperature. You know, this really hits home to, you know, we need to get the scan tool hooked up. I like to do it if they're cold, if they've cold soaked overnight in the shop and it's 70 degrees inside the shop. You know, these sensors ought to report back something pretty close to 70 degrees. And if they're skewed, maybe this is part of your problem. So pay close attention to the temperatures in the system. There's thresholds. You know, how much heat does it take for the diesel oxidation catalyst to light off? How much temperature does it take to have the selective catalytic reduction unit work correctly? These are things that we need to know. So as we go through the oxidation catalyst, it's done its job. It's pulled out the hydrocarbons. and we've generated some CO2, NOx, water, and particulate matter again. So this is the instructor's version, colored right here. So this would be in your instructor's materials, not in the student materials, because the students are going to be asked to do this, where we identify the gases going into the next portion of the system. Well, being the cheater I am, I'd go back to the last slide and look. I got carbon dioxide, NOx, H2O, and PM. So here we have the same thing. Carbon dioxide, H2O, and particulate matter moving through this. Now we're going to add something here. We're going to add the diesel exhaust fluid, which is our yellow color, urea. We're going to talk about urea here in a minute, what it is and what it isn't. So here we are again at the instructor's version, and we're counting on the gases coming through, or counting all the gases coming through in what their constituent makeup is. So CO2, we've got diesel exhaust fluid, water, NOx, ammonia, and particulate matter. And if anybody has any questions as I'm going through there, just put them up in the chat, and Rick or Dick or Tim or somebody, or John will get to me. But let's look at the whole system again. Once again, I think I'm making the point here that we're going to turn the corner and the exhaust flow is going to go this way. So here we are, we've turned the corner. We have these gases that we saw in the 2 slides before. So we have these constituent gases coming through. We're going to introduce them here, and this is the selective catalytic reduction unit. So at the end here, if this device, I won't call it a thing, if this device is operating correctly, we should pull out the oxides of nitrogen. This is the whole purpose of this selective catalytic reduction unit, is to pull out oxides of nitrogen. And there we have it. We had nitrogen, oop, that's the wrong direction. So we had, yeah, that's correct. So coming out of the selective catalytic reduction unit, got CO2, water, nitrogen, and particulate matter. Now, coming out of the diesel particulate filter is going to be the things that we put into the atmosphere. We've got CO2, nitrogen, and water. Now, the only thing that you know, may be a problem there is we're gonna probably have to figure out how to deal with CO2, and that's gonna be interesting. Okay, let's talk about the diesel exhaust fluid. I'll give you a second to read that. So DEF is a 32.5% solution of urea and deionized water. This information is available everywhere. The easiest place is Wikipedia, you can get it under the Creative Commons and share it in a public forum like this, because it's listed as share and share alike. I can't sell it, but I can put it on the screen and we can talk about it. But there's some misconception about what urea is. So here's the technical description of what urea is. I'm going to talk about what urea isn't. If you think about engineering, chemistry, where we've come in combustion technologies for the waste that comes out, these engines are pretty darn clean. I mean, I can get behind a city bus in my hometown that is diesel powered, and I can run my finger with a white glove on around the output of the exhaust pipe, and there is nothing. There is no carbon. So when I see a modern, after say 2010 engine running on the freeway, or a truck running on the freeway with a diesel, and it's making smoke, if I can see visible black smoke pulling on a hill or on acceleration, there's a problem somewhere. And that problem, as we move now, 2017, emissions have tightened up. There's more tightening. This amount that the engine is able to, or the exhaust system is able to give to the atmosphere is minuscule. It's very small. So if you've got trouble, we have to get to the root cause of the trouble. One of the root causes is that people are using the incorrect fluid. So early truck driver stories, it's written on the truck stop bathroom walls, whatever you want to say, is that, well, you can pee in the tank. That's the same thing. And be better off if you could go out into the dairy field and separate it and just use cow urine. Well, here's what the breakdown of urine is. And it's not a 32.5% solution. So I caution you to try to stop the truck driver stories of this misinformation that goes out, because this is going to be very expensive. If you put the wrong things in the diesel exhaust fluid, it's going to be very expensive. Let's just say that. So we went through the last Freightliner class I was in, Swan Island in Portland here a couple of years ago. We did a pretty good exercise where we tested like a dozen different fluids that they had in test tubes. There was light green, there was light blue, there was light pink. There was purple, there were all these different colors, and then there was clear, several different examples of them. And some of them didn't have any smell, some of them had smell. There was no real way to definitively decide which one of those was the correct fluid until we break out the refractometer. So here's a DEF refractometer. We've used these to test coolant for years, right? And other water-based fluids. So the specific gravity of the DEF is a very targeted, specific number. So with the refractometer on the previous page, this is from Bosch, right? And I have to give them credit for Bosch and OTC tools. We've all used that. It's a good solid refractometer. I've used it. It's a great way to check your AdBlue, which is a trade name, I believe, and then also to check your diesel exhaust fluid, which should be the same thing. So this is set at the null point, which is deionized water at 20 degrees or 68 Fahrenheit. Now there's other reticles within this is a view of what's called the reticle within the tester. You can see where the AdBlue is. There's nothing, no liquid, and now there's AdBlue with urea at the proper amount. They had, as an example, some of the fluids were windshield washer fluid. Apparently, this was one of the things that was going around the truck stops, is that, you know, you could fill it with windshield washer fluid and it'll fool it. It'll be okay. Or that you could just fill it with water and it will be okay. Well, water, you know, probably the system will be okay, but it's not, that water is not going to take the oxides of nitrogen out of the system, because it doesn't have the constituent components to make that happen within that catalyst. So it's going to report back that there's excessive NOx. So if we're making excessive NOx, the system isn't working. One of the very first and easiest things we can do is test that diesel exhaust fluid. Pull the lid off the tank, get a look at it, stick your nose down there and see if somebody's maybe put diesel in the diesel exhaust fluid. You know, that's kind of an expensive mistake. You know, you'll probably be changing the tank, the pump, the lines. Not nearly as bad though as putting diesel exhaust fluid in the diesel tank. So if you put diesel exhaust fluid in the diesel tank, which is 62.5% water, and you hit that water with a high pressure fuel pump of say 30,000 PSI, and you try to force that through your injection system, you've got a big problem. This is a very expensive problem. So, and it's not going to be covered on warranty because the manufacturers have kind of figured this stuff out. A friend of mine is the West Coast service manager for Kenworth Trucks, and all the service personnel report back to him. So he has a pretty good handle on what's happened. And, you know, that he said that this is absolutely not, if you put diesel in your, or excuse me, DEF fluid in your diesel tank, this was about 4 years ago we talked about this. He said that's going to be 50,000 for an engine, because you've contaminated all the fuel rails and rifle drillings within the engine, because a lot of those are captured within the cast of the engine. And you've contaminated the engine, and they won't clean it. They won't take it apart and clean it, because they'll have more labor involved and cost than they will be to install a new engine. So be very careful. Your students really need to understand the implications of having the correct fluid for the correct application, and making sure that that fluid is not only correct, but is within its date specifications. I wouldn't use, these are dated, used by a certain date. If I'm dealing with a possible parts cost of $50,000, and without including labor costs and without including truck downtime costs, I think that I'm going to buy the right fluid to put in this, and insist that my drivers or my fleet do the same, because it's a very expensive mistake. So as Rory was talking about in the previous presentation about hydraulic systems, this is another hydraulic system. It's low pressure, but the fluid needs to be correct and the fluid needs to be clean. So definitely I would want to wipe down my filler spout, make sure that if I'm operating in adverse conditions, I'm in a mine somewhere and I'm just caked up with dust, I want to make it so that whoever is filling my DEF tank doesn't have to work too hard to make sure that that fluid going in is clean as clean can be. Very small particles are going to have problems in here. So my point here is be careful about the fluid that you put in the DEF system. Just as careful as we would be about our fuel, about our engine oil, about our transmission and differential fluids, which are often on a 500,000 mile change schedule. 500,000 miles for differential and transmission fluid. And it's no problem because they're using filters, they're using synthetic lubes, and they keep it clean. This is just, the tolerances are just so close that they must be clean. Did I make the clean point well enough? Okay. Other ways to measure that. So there's this electronic unit where you would put a drop up of DEF up on this sensor here. It's going to measure the specific gravity, and it's going to give us the output. There's also, this is sourced from Amazon. There are knockoffs on these urea testers, specific gravity testers. I can't speak to any one of them, you know, whether they're good or they're bad. Caveat emptor, buyer beware. But I do like the reticle on this one because it's normed to the specific gravity numbers that we're all used to in measuring acids and bases in chemistry, if you remember that far back. But it also gives a free scale for both propylene and ethylene glycol, and the free scale for washer fluid, windshield washer fluid. And then up here in the corner is the urea. There's the link. You can research that. Okay, here's another view of the system from Cummins. We're OEM for Cummins. We build a lot of Cummins engine benches as trainers with fault boxes. You know, it'd be pretty cool if we put that student learning platform on one of the diesel engines, and you know, I think that might happen in the future, that we have a student learning platform and a tablet on diesel engines. And it may be with a Cummins. You just never know. But anyway, Cummins lets us use their materials since their offshoot, Donaldson and others, depends on whose fleet guard, whose name they put on it. But here it shows the DEF injector, selective catalytic reduction catalyst, and then a slip catalyst for any amounts of ammonia that weren't broken down into nitrogen. So hopefully that comes out of the tailpipe with less than 10 parts per million. So just a different view of things. I'm going to now get into some different views. Again, oxidation catalyst, particulate filter. In this case, they're going to run it right after the oxidation catalyst. I think they're playing on a lot of this has to do with how they create the heat to generate regeneration, and some manufacturers do that with a extended injection process in the engine. Some of them do it with a what do they call it? The seventh injector on a diesel engine to inject fuel, so we can keep the heat up, so that we can get the regeneration through the diesel particulate filter. And as you can see, they've switched the order a little bit from what our trainer is. Does the same thing. Going to have the same output out of it. I'm not going to show this video. I'm going to get back into a review, and then there's some other documentation that I want to go over and show you, and then keep your questions going. We'll have a few minutes, maybe 15 at the end, before we get into that last little bit at 4 o'clock. So let's review here. So diesel particulate filter, we're going to talk about that a little bit because we've got to get rid of this particulate matter. So a diesel particulate filter flows through the wall of the substrate. So think about that for a minute. I like to view or have my students visualize that this is very similar to a paper air filter element or an air filter element that may contain paper. The only difference is that this is a ceramic. So, you know, like the concrete blocks that you may have on your property, you know, a lot of water will pass through there. They aren't impermeable. This is also permeable, so that the gases flow through, the particulate does not. And this is a series of tubes, and I'll show a picture of it here in a minute, a series of tubes that the adjacent tubes are blocked on one end or the other to create this labyrinth that the exhaust must flow through. It won't flow through here, the end, but it'll flow through the side of the substrate. So this is really important. This is very controlled manufacturing. You know, I've seen a lot of discussion about regeneration troubles. What do I do if I'm in the, well, school buses, transit buses, garbage trucks, mixer trucks, pickup and delivery. Those short hop vehicles, early on when we started using particulate filters, they had a devil of a time keeping them regenerated because there was so much stop-start. There was so much soot generated that didn't have time to be regenerated into ash. Let's talk about this ash for a minute. You've probably all maybe barbecued and you've fired up a set of briquettes. So you've got that nice charcoal block, maybe you're using lump or whatever else, but you know that the volume of that, when it's heating, is reduced to ash when it's done. It's the same thing that's happening here. The volume of the black stuff is the soot from the engine, and it's going to be reduced to the ash that we would see in a similar ratio of volume as you would see from a briquette. So, you know, an air filter plugs up. Mr. Curtis, can a diesel particulate filter plug up? Yes, it can as well. At this point, I would like to switch screens. I'm going to go to a document from the American Trucking Association. I've got permission from them to share this on the screen, but not as a document. This is a transitional document. It's not been fully approved for publication, but recommended practice, it probably has been approved by now. Recommended practice 374 is the is the cleaning of the particulate filters and oxidation catalysts. So within the trucking fleets across America, and this is the American Trucking Association. So, you know, when I first came across the TMC, the Technology Maintenance Council of the American Trucking Association, I looked at buying some of their recommended practices. And it's not a cheap book, but it's an extremely thorough book. And I got over that worrying about the price because it's priceless. Of all the recommended practices that are in there, I started teaching from this, using it as an industry standard textbook. It's not a textbook, but it goes into the technical aspects of all of these products or all of the recommended practices. So, you know, there were people that got into the particulate filter cleaning business, and there are many reputable particulate filter cleaning services where they go in and they have their own ways of cleaning. And the trucking industry came up with this, TMC came up with this proposed practice of recommended cleaning methods. So, you know, I'm not going to read through the document, but there are some pictures here. I told you I was a visual learner, so I have to go to the pictures. But also be aware that, you know, these other RPs, the 355, the 360 deals with diesel exhaust fluid, 372 diesel exhaust fluid tank design guidelines, and the after treatment serviceability guidelines. These are all excellent documents that come within the book of recommended practices. And I encourage any heavy duty instructor that's, especially if you're in a heavy duty trucking fleet, you know, if you're in Florida, maybe you can get Southeast Freight Lines to spring for you, and you could get a copy of this from them. I don't know. I'll just throw them under the bus. I met their service director. He's a really nice guy. So hit him up. Tell him I sent you. Okay. Let me just go through maybe some of the non-recommended practices. So a steam clean or a pressure washer. You're worried about washing away the coatings within these units. You know, I just watched a video of earlier this morning from Tacoma, Washington. The guy's Ring doorbell camera recorded two guys pulling up in a little white car. They jump out of the car with a Sawzall. They crawl underneath a Ford pickup. They cut a piece of the after treatment system out and run to their car, and off they go. So we're seeing this because of the precious metals that are within this. If you've looked at rhodium prices recently, or platinum or palladium, you know, the prices have just gone through the roof. So people are stealing this stuff. Well, we certainly don't want to wash it off in trying to clean it. So this goes through, you know, blowing them out, drawbacks, pulse, high frequency vibration, all those things to go through it. And then testing. So up here, they're using a pin to measure the depth of the little, one more page, Jeff, these passages in figure 9. So this is a picture of the face of the diesel particulate filter, one face. The opposite side would have the other end would have the opposite end of these little passages blocked. And it's ceramic. right? So this is brittle stuff. So what they're showing here is using a piece of steel that fits easily down into the chamber, and measure how much soot is there, and then come back after you've taken those briquettes and you've turned them into ash, how much is at the bottom of the pin or the rod when you measure it. So pin gauge, 32 to 34 thousandths in diameter, stainless steel wire, about 24 inches long. Okay, so you can go to the welding supply place, pick up some steel welding rod for torch, and that would work, or another rigid piece of wire. You're probably not going to want to straighten out a piece of mechanics wire to try to put down in there, or tie wire. So there's a lot to also the inspection of the substrate itself. So in figure 4, we can see ash on the table, and soot. The presence of soot is normal on the outlet of the diesel oxidation catalyst, but and then here are pictures of the diesel particulate filter faces. They're soot bypass or breached DPF by shining a light through it. See, they're shining a light on figure 9 at the other end of this, and right in this area you can see that the light is coming through. So that's a failed cell. So that they give you how many can be failed, or they can also show that the face contamination is excessive, and you know, you might be out of luck for trying to reuse this. Here's some that, like figure 12, it's coming apart. All of these are done. You will be replacing them, especially if they're cracked. You know, it's a very brittle substrate, and it's fragile. And they don't seem to have a lot of trouble unless, you know, you've got other things going on in the system. Some of the brackets I've heard been breaking, and then they rattle, and if they rattle too much, the vibration is going to set it up for failure. The other things that, you know, all of us were in Quebec one year, and a couple of years ago, and a guy from a trucking fleet came through, and you know, there's 500 power units, and they're just having a devil of a time finding somebody that knows how to fix exhaust after treatment problems. This is a hot button for your training programs. If you can go to the service manager at the local Freightliner, PACCAR, Mack Volvo dealer, I hope I didn't leave anybody out, and demonstrate that you can troubleshoot exhaust systems and the sensors within those systems, you're going to be a hot commodity. Do I do this, or do I do brakes? I think I want to be on the high tech part of it, and maybe I learn about this. Anyway, the story goes, the guy, they had a truck that kept setting a SCR code, excessive NOx, and it would go to a dealership. They would hook the scan tool up, and oh, it's a NOx sensor, replace the NOx sensor. You know, they're only 480, 500 bucks, you know, plus the labor. 40 miles down the road, it sets the code again into the next dealership. The next dealership hooks the scan tool up, and they say, oh, well, it's a NOx sensor issue, and we'll replace this NOx sensor. $480, $500. Well, so this goes on more than twice, let me just say. And finally, they start questioning what's going on. And they find that they have an air leak. There's a hole in the exhaust system. So remember early on when I talked about this is a closed system and we're measuring the inlet volume and we're measuring what comes out. If we introduce atmospheric at any place within the system, we've skewed how the system works. We've diluted the stream. The stream can't be diluted. So this hole that they found on this truck, on this fleet of 500 power units, was a hole in the canister itself over behind the front tire where the road sand and the salt or whatever else they've put in the roads has beat a hole, a small leak into the exhaust system. And they had more than 2 NOx sensors at around $500 just for the part installed. And it didn't solve the problem. So if you can troubleshoot diesel exhaust systems, you're going to be hot stuff if your students can. Some more photos. This is a great, I think this is a great document. Here's some tools you might use: a borescope, X-ray and ultrasound. Well, that's not widely used. Thermal imaging, you might be able to see something with that. I haven't experimented with a thermal camera on these. But if you're working within a fleet, you've got lots of power units, you're going to be very familiar with the after-treatment system, especially in just maintaining it. Making sure that it has clean fluid, it has the right fluid, that the closed system remains closed, you don't have air leaks. So these are the important things, and then being able to see those, interpret those things within the scan tool that fits the application. And if I was working on a Cummins engine, I would have Cummins Insight. If I was working on a PACCAR engine, I would have PACCAR Davy. I would have the manufacturer's scan tool. It's the only way that you can get a lot of these codes accurately. Okay, what's this? Oh, oil, fuel and oil. Got to have the right fuel. We must have the right oil. If we over service the vehicle, let's say we've got a factory 15,000 mile oil change, and we decide that we want to change it every 5,000 miles. Well, the total base number, the additives of the oil, have been engineered so that when we burn oil, because we're going to burn a little bit of oil, we are going to put that oil through the exhaust. Well, we had to get rid of most of the zinc, which is one of our popular anti-wear additives, because zinc would poison the catalyst. In the fuel, we got rid of sulfur, because sulfur would poison the catalyst. So here we've got fuel that doesn't have hardly any sulfur in it. I mean, it's 15 parts per, it's very low. It's parts per billion, I believe. And then we've got engine oil that we hope the operator is using the correct oil. If they're using the correct oil, they don't need to be over changing it. If you've got a condition that makes you want to change that oil sooner than it's supposed to be changed, how do we change that condition so that we don't overchange the oil? Because we're going to burn off those parts of the total base numbers the additives of the oil, that's going to go through the exhaust system. So we have to be careful of that. But then we really need to be careful of what oil are we using. Are we using the recommended oil for this engine and this application? So, you know, I've talked to a lot of big fleets. I always use 1030. I've used 1030 in all the cars, all the pickups, all the trucks, all the cats, all the hydraulic systems, because my operators, you know, more than one choice is not a good thing for them. Well, maybe it's time for some operator education, because we've taken it up a notch, a few notches here. So we need to be careful what we put in the engine, because what we put in, what we reap is what we sow, right? This is gonna come back to haunt us. These are not inexpensive troubles. These are expensive troubles, and we want to avoid these as much as possible. And I think that comes through driver education and also your service education of your service staff. That starts in our programs with our students, so that we can, I know all the young guys, they want to roll coal and they want to do this and they want to do that. And, you know, I have to remember that I was 16 once. I really liked horsepower and trucks. You know, we hopped a lot of stuff up. We made a lot of black smoke. I'm not so interested in that anymore. So here's the how to evaluate. This is a pretty comprehensive document. I'm obviously not going to read that to you, so let me get out of this, back into the slideshow. I don't think I had anything else up here I wanted to see. Here's just another view of how the gases flow through the system. I always like to have multiple views. Again, this is the briquettes coming in, and we're going to turn them to ash. And when I say briquettes, I mean, you know, they're very small pieces of particulate soot. It's just the visualization, if you will. So when I do these presentations and I'm able to have feedback, I always want feedback, and I put this up here because I do this with my classes. I always want to have a couple of questions. Did I do a good enough job of covering the things that, you know, are going to be on the hands-on portion of the instruction? Because I would rather test through hands-on. Show me that you can do this rather than check off the A, B, C, or D on the multiple choice test question. That doesn't tell me if you can do anything. I want to see if you can do something. So, you know, I didn't, in the first time I presented this, I didn't talk about the decomposition tube. And so I changed my presentation a bit. So there's my contact information. J. Curtis, ConsuLab.com. As John said earlier, I'm deep into the heavy duty product. You know, I like doing these on Aftertreatment. We've got an air brake board, HV125 BWP driving simulator. I hesitate to call it an air brake board. That is really hitting the country by storm. We're a little bit behind in production because we've sold way more than we thought we would have. And then, you know, of course, all of us are deeply into electronics as well. And I can only bow to those that are greater than me. Rick and Dick and Al and Tim are just, they're really great people to talk about technical stuff with and plan. This job's been a lot of fun. Let me go back here. Let's just go. Right there. I'll stop sharing.
That concludes this session. Thanks a lot for watching. Now for a quick word from our sponsors.
This is a 2014 Peterbilt that we've transformed into a training aid. Now we can do this for Cummins, Caterpillar, John Deere, Mercedes engines, anything you can imagine. So what does a diesel engine bench like this look like? We've got the control panel for the instructor where we've got an instrument cluster, J1939 CAN bus instrument cluster. We've got test points for all the wires going to the control unit. We've got our controls for things like the PTO, for the Jake brake, for the fan clutch, for regeneration, brake pedal, clutch pedal. We have our gas pedal down here, and we have taken all the components off of the vehicle and we've made it easily accessible and teachable for you. We've created our own small fuel cell, we've added a fault box, but everything else is from the truck. So this is a Cummins ISX 15-liter engine. We've got the air-to-air radiator from the truck, but you can see that we've taken it and we've made it safe. So we've put protective grills over all the rotating parts. We've put protective grill over the radiator and air-to-air. And we've added things to make it easier in your classroom. So your battery packs are here. You've got an integrated smart charger so you can leave it plugged in. And then what we've done is we've taken the after-treatment system and we moved it off to the side so that your students can do further analysis of the system and better understand in greater detail how the after-treatment system works. So we've got the DEF tank, we've got the DPF, the diesel oxidation catalyst, the selective catalytic reduction, as well as all the sensors that go along with it. So let's fire up the engine and see what we can do. So now, using the fault box, we can insert all kinds of different faults and scenarios. So I've got a computer here, tablet computer. I'm just going to take a USB cable and plug it into the fault box. Now the faults that we can insert with the fault box and using the software on our tablet computer, they're not just simple open circuits. We can change circuit voltage, circuit signals, and we can do all of those faults intermittently. So I'm going to fire up the engine and we're going to see what we can do. Good luck to your students in figuring out those problems. Now, using the integrated breakout box, we can use either a multimeter or an oscilloscope, and we can take measurements of the different sensor signals. Now we've got a guide for all the pinouts that is there for the students and the instructors. Let me introduce you to an exciting new product from ConsuLab Training Aids. This is our EC490 cutaway diesel exhaust system trainer. And this product has been developed specifically for teaching the complex molecular changes that we see inside of a diesel after-treatment system as the exhaust passes through the system. Now here we have the protective plastic cover that encompasses all the components on the product. And you will see at other points in the video that we've removed it just to avoid reflections, make it easier to see the components that we're filming. Now this cover is there for a couple reasons. It's to keep the product clean. It's also to keep your students and you from getting too close and poking around in the catalytic converters and the DPF. Now, I also want to talk about space because this product is made to fit through any door, it can fit into an elevator, and it doesn't take up that much space in your classroom or in your shop. Now, what we've done with this product is to take the physical components, such as the diesel oxidation catalyst, the injector, the mixer, the SCR, and the DPF, and to incorporate it with visual animations that show the flow of exhaust and the molecular changes that happen inside. So we can see at the beginning, we come in with certain molecules, we're going to pass through the DO3 and all the way through the different components right through to the end. And as an instructor, you have the choice to go through both in automatic or in manual mode. This allows you to put a focus for your students to see a specific area and have them go through and analyze it. So from the product control side, we can just plug it in, turn it on. We've got a play button. and we can adjust the speed as we're going through. We can see differences. This is great for an open house, or if you're doing a show, you can just demo it to your students. Then we can press on pause, and we can select the different modes. Now it's important to note that when we're in the automatic mode, we go through a regular sequence of exhaust treatment, and then we go into a regen. And we also have a regeneration button here that'll force it into regen. Now you may have noticed that we don't have any indications on the product explaining what each stage is, and that's because this is designed for your students to interact with. You'll see there's different numbers identifying different components and stages in the system, and this is to go along with the student exercises and curriculum that we provide with the product. Now, the product has really been developed for teaching the fundamental basics of a diesel after-treatment system, so it can be applicable to light vehicles, heavy vehicles, off-road, anything that has a diesel system with urea injection and the various components. Now, some of the components, depending on vehicle, can be located at the back, like the DPF here, or at the front. It could be in a straight line, it could be in an S configuration, it doesn't matter. This is for teaching the very basic fundamentals of the system. Now, as you've seen, this product can make your life easier as a teacher. To find out more about our products, please visit ConsuLab.com, and you can follow us on Facebook, Twitter, or LinkedIn. Thanks for watching.